Welcome, everyone, and thank you for your interest in the IHE Pathology and Laboratory Medicine domain, also known as PaLM, in our update webinar today. I am Mary Kennedy, Director of Clinical Informatics Initiatives at the College of American Pathologists and Primary Secretariat to IHE PaLM domain. Our speaker today is Riki Merrick. Riki is a planning co-chair of IHE PaLM. She is a licensed physician in Germany, received her Master in Public Health from the University of California, Davis, when she started working on HL7, LOINC, and SNOMED. After 9 years of working as a consultant for the Association of Public Health Laboratories, she is now staff, serving as the informatics program's lead terminologist, providing implementation assistance for electronic data exchange for surveillance, ELR, and case notification initiatives. She also consults for NIST on the development of test cases for lab-related message validation tools. Riki participates in several national vocabulary harmonization projects in the laboratory and public health domains, in leadership roles at HL7 Orders and Observations Working Group, and the Lab Messaging Community of Practice, as well as laboratory-related S&I framework initiatives. Thank you all again for attending today's presentation. I will now turn over the presentation to Riki Merrick.
Hi, good morning or good afternoon, whatever time zone you're in. I'm going to give you a brief overview of the agenda. So I'm going to talk a little bit about IHE as an organization and as the process that it's developed. And then, obviously, most of the time is going to be spent on the pathology and laboratory medicine domain, its mission and scope, the available integration profiles, upcoming connectathons to test those profiles, our current project, and last but not least, how you can get involved. So you've already heard Mary use several PLAs, or three-letter acronyms, and we also have FLAs, four-letter acronyms. And so I've tried to be really good about, in the notes, if those are available to you, to spell out what each of these acronyms mean. But I also have a glossary slide at the very end that you could look these up. So hopefully you're not going to get too confused with the alphabet soup I'm throwing at you. But that's just jargon around here. So IHE stands for Integration to Healthcare, Integrating the Healthcare Enterprise. And why would you use IHE? We have international standards that are usually state-of-the-art interoperability solutions, but they are often made so that they can accommodate all sorts of use cases, all sorts of situations, so there's a lot of optionality in the underlying standard. And they also talk about how they are used, but they don't necessarily talk about how to use themselves with other standards together. So in order to tackle a health data exchange problem, you usually need to use more than one standard. So how do you do that? You use IHE profiles. So IHE basically looks at the best available standards for a specific problem or use case, and then identifies those standards and puts them together into an integration profile that helps you properly address the use case and have a successful data exchange project. So IHE per se is not a standards development organization, but it does promote the coordinated use of established standards, and it does provide feedback to the individual standards for improvement over time through their implementation. Some IHE basic terms, I've already used the first one. It's an integration profile. The integration profile is the description overall of what the problem is from the user's point of view, and then how the solution will be implemented. And it does not impose any particular architecture requirements on the systems, and it doesn't constrain the different setup within your application at all. What it does do, though, it identifies specific roles and specific requirements and responsibilities for those roles. And those functional parts are called actors. And within a use case, we're talking about data exchange, there'll always be at least 2 actors, and those 2 actors are being connected by a transaction, so the data flowing from one actor to another. So in this example, we have an order filler, the lab that has finished a test on sodium level here and is ready to send the results back to the order placer, but in the IHE profile, this is called the order result tracker because this role can be played by multiple different IT systems, for example, a CPUE system or a hospital information system or any other kind of electronic health record system. So how did IHE come to place? So in 1998, HIMSS and the RSNA, the Radiology Society of North America, decided to work together to collaborate and define integration profiles for the radiology space. So how can we safely and effectively exchange image data information? And then IHE grew by domains over time, as you can see. So laboratory, cardiology, and oncology and patient care coordination kind of started pretty early, and then later on other domains joined. Each domain has a planning committee and a technical committee, and in some domains those combine to a single committee, which is the case for PaLM. So the IHE process is pretty specific. First, you build an integration profile, and as part of that integration profile, you define the use case, you select the standards, and you publish the integration profile as a trial implementation profile. Developers and vendors can take that integration profile and develop their application, and then test it at a connect-a-thon, and I'll talk more about that in a minute. And during those tests and during the implementation, there'll be items that are being identified as not quite working the way they're described, and so the integration profile gets optimized and retested at the connect-a-thon. And when the connect-a-thon, when there's been enough connect-a-thons and the integration profile doesn't have very many changes after several connect-a-thons, it's considered ready to be moved into final text into what's called the technical framework document. Again, the results from connect-a-thons can be published in connect-a-thon results tables and in integration statements. And when you, as an organization, are looking to tackle a specific use case and you're looking for a product that can help you do that, you can specify the IHE integration profile in your request for proposals from vendors. You could also look at whether the vendors that submitted or responded to your request for proposals have an integration statement or are published that they have tested that integration statement, that integration profile at a connect-a-thon. So connect-a-thons, those are week-long testing sessions that are organized annually across the different regions of the world. They enable IT vendors to come and bring their applications and test them, against the specification itself, but also connect with their peers. So each IT vendor represents one actor in the integration profile, and they find another IT vendor that represents the other actor, and they actually hook up and make the data exchange happen at the connect-a-thon. This setup accelerates the refinement of specification because we all know the devil's in the detail. So until you actually try to make these specifications work, you won't find all the little nooks and crannies and surprises that are hidden. And as I already mentioned, once a integration profile has been tested several times at a connect-a-thon and it seems pretty stable, it becomes integrated into the domain's technical framework. So much for a general overview of IHE and the process we're employing. And now I want to talk about mostly the pathology and laboratory medicine domain. We are brand new, born this year, out of a merger of the anatomic pathology domain and the laboratory domain. And our scope is, and I'm going to read this, clinical care-related representation and exchange of digital documents, structured data and images associated with ordering, scheduling, performing, and reporting diagnostic observations on in vitro specimens collected from a patient or a non-living subject. The workflow, representation, and exchange of structured data related to specimen management, secondary use and exchange of observation results, and the logistics and clinical data related to the long-term storage and use of specimens when a pathology laboratory is involved. So anytime a laboratory deals with any of these use cases, PaLM domain applies. Where it wouldn't apply is for point-of-care testing that is not supervised by a laboratory. That part is taken care of by the patient device domain. The IT systems in scope for the PaLM domain are any kind of electronic health record system, of course, the different types of laboratory information systems, health information exchanges, robotic specimen container distributors, barcode labelers, any of the robotic devices that help with automation within the laboratory, naturally the testing equipment that actually performs the testing, any middleware that helps translate between any of these systems within the laboratory. And of course, since we're dealing with imaging modalities, picture archiving, and communication systems, and biobank management systems. So it's quite a broad range of systems that are affected by the PaLM domain. The final text is the technical IHE PaLM Technical Framework, version 7. It was just published this month. And it and every technical framework document is broken up into 3 volumes of text. The first volume presents the use case, so that's the user view. What's the problem? What are we trying to solve with this integration problem? And what are the requirements that we're trying to solve? And then the volume 2 and volume 3 is the implementer view. And you can see we have multiple different volumes because we are covering quite a bit of profiles here. So the profiles covered, and I'm going to talk about them in detail later, are listed right here. And I'm giving you a link to that technical framework where you can find it. And then we also still have trial implementation supplements. Those are still in the respective domains. So for the lab domain, we have the InterLaboratory Workflow and the graphics and simple images and results option for the LAEW profile. In the anatomic pathology domain, we have the anatomic pathology workflow in hospitals, the anatomic pathology structure report, and the pathology report to public health. I give you a link to the descriptions of these profiles. The descriptions of the profiles are in the PaLM domain, but the actual texts, you'd have to go to the respective lab domain page or the anatomic pathology page to download those. Okay, so picture is worth 1,000 words. So basically a list, again, of the PaLM domain profiles. What this shows is that some of the profiles are solely in the lab arena. Most of the profiles connect the care providers with the laboratories. Some include where specimen could be collected, which is not necessarily just at the care provider. And then it shows how, even though they are not specifically part of the PaLM domain profiles, all of our profiles leverage other IHE profiles to deal with security and constant time, to deal with good representation of patient data, and for some of the profiles that are document-based, it uses the standards described for document sharing. So a little bit in detail about the established profile. The first one is a laboratory testing workflow. It deals with anything you can think of that you might need between the provider and the laboratory: ordering, scheduling, processing, and result reporting. So we have 3 major use cases depending on where the specimen is collected. We already talked about the systems involved, so we're talking about the systems on a provider side and the system on the lab side. And we're using a HL7251 messaging standard as the basis here, and we're doing it because it enhances the quality of care, because it reduces manual copy and redundant orders. It can help identify when specimens are lost or orphaned, and it definitely reduces transcription errors. It also increases throughput because it saves on phone calls and test scheduling and processing and reporting. So here's a picture of how it works. You have the provider that places the order to the laboratory does their testing and then reports the results back. And this picture also shows how it leverages other IHE profile. The laboratory point-of-care testing profile. So this is point-of-care testing that is supervised by a clinical laboratory of the institution. So in this case, the test is done at the bedside, but it is supervised by the laboratorian in order to ensure that the level of quality for the testing is the same as if it was done in the laboratory. The standard is actually a standard from CLSI, which is based on HL7251. Again, the picture, we have the point-of-care testing machine, so to speak, that initiates the testing and produces the observations, and then the accepted observations get transferred to the laboratory information system that plays the role of order filler that can consolidate orders and consolidate results on the same patient. Now we're moving slowly into the laboratory space. These are established profiles for automation or robotization. So one is barcode labeling, which basically ensures that the correct container is labeled with a barcode for that specific patient and specimen. And so that helps avoid selection of inadequate containers, because the containers are basically provided to the specimen collector with the right patient information. So unless they make a mistake and put the wrong person's specimen into the container, there is less problems this way. And the lab device automation, this automates all the different steps that a specimen might have to go through before it's actually tested. So, for example, you might get a tube of blood, but it needs to be centrifuged before you can use the serum or the plasma for testing. You may have to do more than one test on that one specimen, so you'll have to aliquot it, and you may want to store specimen over time. So combined with the laboratory testing workflow, this really ties the whole workflow in the laboratory together. Another established profile is the laboratory code set distribution profile. So this basically lets the LIS that owns the code, that has all the tests that can be ordered, the tests that can be run, and the results for those tests available, and shares it with the application that will be allowed to order those and receive those results. So being able to do that and sharing all that information in a specific format will reduce the time to configure connections between the two systems, and also reduces the maintenance of the interfaces over time. And we all know that laboratory tests get updated and renewed, and so that takes care of the initial load as well as updates to the information over time. And one other profile that's established is the Sharing Laboratory Reports, or XPLab. This one, so all the other profiles so far use the version 2 HL7 standard for messages. This one is based on the version 3 clinical document architecture standard. It also uses LOINC, logical observation identifier names and codes, to identify tests as well as document sections. And it's using UCOM unified codes of units of measure to describe the units of measure. What makes CDA different is that CDA has a human readable portion as well as a machine processable portion, and the idea here is that the human reads the text that is produced from the structured data that the machine can process, so the human reading the text and the machine processing the data both have the same information. That's the idea. XPLab is also, besides carrying laboratory results, able to identify reportable conditions or outbreak information, so it can be used in public health reporting. It is a national standard for laboratory result reporting in several countries, Austria, Switzerland, France, and Saudi Arabia. It's also regionally used in other parts of Europe, North America, the Middle East, and Asia. Oops. Okay. And our newest final text profile is the Laboratory Analytical Workflow, or LAEW. It was a multi-year joint effort between the IHE Lab Committee and the In Vitro Diagnostics Industry Connectivity Consortium, basically a group of all the vendors of these test equipments got together and decided that it would be really helpful to describe a profile that can be used to connect the instrument that's doing the testing to the LIS that has to report the results. So you can imagine that if you are a laboratory and you offer a set amount of tests, that you have to deal with quite a few different kinds of instruments to connect to, and so having the standard identified that's viable for most of the instrument vendors makes it really a lot easier to make those connections. So what does the LAEW profile describe? It lets the analyzer ask for, what work do you have for me? It lets the analyzer manager, or which is the role for this profile, tell the analyzer, here's what you need to do. And then it lets the analyzer report on what it did. So the report could either be the result, but it can also be, I couldn't do the test because XYZ. This uses HL7251 messaging, but it did pre-adopt quite a few constructs from the latest version 2.8.2, and 2.9 is being valid this September, so a couple of adjustments to the base standards that are in 2.9 we have pre-adopted here already. LOINC is recommended to identify the testing performed, and UCOM is recommended for the units of measure. It is the basis for the new CLSI standard titled Next Generation IVD Interface, or Autumn 16, which will be published beginning of 2017. The other interesting or new thing about LAEW is that it's one of the early profiles, at least as far as I know, the first in the laboratory domain that has a conformity assessment available for vendor use, so that vendors not only can test it at Connectathon, but can actually get their conformity assessed and then be certified as a conformant system through IHE. So those were all the profiles that are available in final text. Now we're getting to the trial implementation profiles, and I'm kind of going chronologically here. So the InterLaboratory Workflow is one of the trial implementations that's been out for quite a while. It deals with the data exchange between laboratories. So if This first laboratory has 3 tests ordered from them, but they can only perform 2 of them. They subcontract out the third to another laboratory, and that laboratory might need to perform a reflex test and report both those results back, and then this first laboratory uses the LAEW to report back to the ordering provider. This also uses the 251 standard, LOINC and UCAM. The anatomic pathology workflow is similar to the LAEW on this side because there's really not that much difference whether you order a chemical lab test or a microscopy. Where the difference occurs is in the results handling, because in anatomic pathology, as you all know, a lot of the results are actual images, and so that causes you know, other interesting problems that need to get solved. So the anatomic pathology workflow really is focused on dealing with the image handling, proper image handling. It's using HL7251 LOINC and then DICOM for the imaging part, and SNOMED CT for results and specific diagnosis. The anatomic pathology structure report is similar to XPLab. It uses the clinical document architecture, LOINC, DICOM, and SNOMED CT, and it is created for the transmission of results for anatomic pathology specifically to the ordering provider. And it has specific sections to cover all the different aspects of an anatomic pathology report, the history for that specific illness that's being investigated, intraoperative observations if that's appropriate, macroscopic descriptions, microscopic descriptions, and most importantly, of course, the diagnostic conclusion section. But it also has a section describing specifically how the specimens evolved through the process of the anatomic pathology workflow. Similarly, we said XPLab can be used for reporting to public health. Well, there is a profile out there that takes anatomic pathology reports and allows them to be reported to public health. This is basically for, or most commonly used for cancer registry reporting. It's a 251 standard with LOINC, DICOM, and SNOMED CT. And you see here the anatomic pathology workflow, and it's basically taking the resulted part from different laboratories and allowing it to be transmitted to public health organizations. All right, so all of these profiles are available for upcoming Connectathons, and here's the list of them. So the next one is in Tokyo, Japan in September. So, and then the North American Connectathon is in January. The registration for it will open in September. And then, of course, you might want to mark your calendars to go to Vernetzt in April. Sounds like a great place to have a Connectathon. So if any of those profiles are interesting, consider taking your product to one of these Connectathons and testing it there. On the image, you already saw a few profiles that I hadn't mentioned before, and these are profiles that have started working on a while ago, and they're still under construction. We're hoping to wrap these up. So the first one of those is the Laboratory Clinical Communication, or LCC profile. And this expands on the laboratory testing workflow and for some specific purposes. So the first problem we're trying to solve is when a provider orders a test and the laboratory thinks there's a better test that they should be doing instead. Maybe because there's not enough specimen and this other test will provide similar information, but with a reduced amount of specimen is still doable. They could send a transaction proposing a replacement order, and then the order placer or provider can say, yes, okay, go ahead and replace it, or no, I don't want you to replace it. And as you can see here, the communication in this case, from the order placer back to the laboratory, would use the laboratory testing workflow transactions, and the new transactions was the proposal of a replacement order. Likewise, so this is kind of a, you told me to do something, but I think you need to, you know, consider something else. Well, we're creating a similar transaction for that, where the provider says, okay, you sent me this result, but it really doesn't seem to make sense in my patient or for some other reason. So can you please verify that that result you sent me is correct? So that's the other LCC transaction, and then the filler can do whatever they need to do to verify, and then send either a correction or a confirmation back to the provider. So this also will use the 251 underlying standard and LOINC for identification of tests. On the laboratory automation side, we have captured the working relationships between the automation manager and the testing equipment in LAEW, and we've captured the working requirements between the pre and post processing, like PCAPR, centrifuges, aliquoters, and the automation manager in LDA. What we don't have right now is really well defined is how do the specimen get from one place to the other. And so that's what the specimen handoff is working on. So it has a specimen transport manager on one side and a specimen for processing device on the other, and it's defining how these two interact when the specimen is presented for aspiration, for example. This will use version 251 message structure, and we'll probably pre-adopt a few constructs from version 2.9. So those two we've been working on for a little while. This year we started working on the specimen event tracking. This is providing a framework for instrument vendors to manage specimens passing in between different parts within the same laboratory or across different laboratories. So oftentimes it's really important for the result interpretation to know what has happened to the specimen before it got tested. And so this specimen event tracking profile will take care of that in terms of where it was, how long it was, in what environment. And we're at the place of defining a use case. So we're describing all the different places where we might need this profile and the requirements around them. So far we know we're going to use 251 HL7 messaging as the underlying standard for this. We might pre-adopt some items from 2.9, but any other standard we might need, we don't know yet because we're still in the use case gathering phase. Other current projects, this is one that's been around for a while and hopefully comes to a conclusion here pretty shortly. It's taking the IHE integration profile, sorry about that. It's taking the IHE integration profiles and comparing them against the U.S. realm lab-related implementation guides that were developed pretty recently on the U.S. side. And the idea is that hopefully we can identify if there are any gaps, how we can close them so that ultimately the U.S. realm lab-related implementation guides are more specialized versions of IHE integration profiles. And this is a joint project between HL7 Orders and Observations Working Group and our domain. Another current project is to take the anatomic pathology structure report that is currently a trial implementation profile and generalize it a little more, and also move it into our tool that we can use now for IHE content development, which is Art Decor. And what we hope to do with that, by moving it into Art Decor, it'll make it easier to develop the specification, because we can, the tool allows only allowable constraining, which means you're always allowed to make something more strict, but you're not allowed to make it less strict than the base standard. And so using a tool will help you do that, but it also creates an output file that describes the conformance rules for testing the profile. And as the existing anatomic pathology report, it is a clinical document architecture based, and we're not changing that or the other related standards around it. A project that we're just starting is to take the anatomic pathology workflow and integrating it into the PaLM technical framework. And I've already kind of alluded to it a little bit. We're going to break the anatomic pathology workflow profile into 3 parts. The first part will integrate pretty easily with existing transactions from the PaLM technical framework for ordering and scheduling of testing in the anatomic pathology domain. Part 2, this is really where the prior work from the anatomic pathology workflow will be reused and create that as a smaller profile that's hopefully more manageable for folks to implement. And part 3 will be looking at additional capabilities of imaging and image exchange. So you're noticing that there are some RAD transactions here, so they come from the radiology domain. There are a couple of other radiology domain transactions that we may consider using in this environment. And last but not least, we're going to create a white paper to describe the data element registry or repository. Well, what is that, and why would we want to do that? So when we're doing electronic data exchange, we're really taking specific data elements and moving them from one partner to another. And in order to have that be meaningful, both partners need to really understand what that data element is about. And so what this data element repository or registry would do is it would create a place where each data element has appropriate tags, the metadata, and the context that just clearly describes the meaning and lists the allowable vocabulary binding. So what vocabulary standards can I use to describe this data element, and has that available. And then for a specific transaction, you would say, well, I need to describe this data element. You can go to the repository, you can pull it out, and you can say, okay, so now for my use case, I need this data element to be grouped together with these other data elements, but only if X, Y, and Z applies. So what we want to do is be able to have not only the data element by itself, but create templates in which these data elements are used that capture the business rules, specific guidelines for a specific use case that can be, at the domain level, but it could also be in your organization. How do you want that specific data element be used in this context? And then at that point in time, at the template level, you would probably choose a specific vocabulary to bind to, whereas at the data element level, you may have multiple options. So for example, SNOMED CT is a viable terminology for use. However, either you have to pay for each individual use, or you have to be part of a member country. So if the country is a member of IHDSCO, then you can use SNOMED CT at no cost for you. So some countries are not members, so they may not want to use SNOMED CT. They may have another vocabulary that they can use instead. So at the data element level, that would be, there would be different options. But in your specific setting, you would be able to define the binding. And then other partners, these templates would also be available. And so if other organizations have the same rules, they could just use your template. Or they can use your template and tweak it a little bit and then put their template into other repositories. So we introduced this to the Domain Coordination Committee, which is IHE's, it's a meeting of IHE domains, so that we all know what each other is working on. And when we introduced this, there were several other domains that said, yep, we're working on that too. So The idea here is to first write a white paper and solicit feedback across all the IHE domains on how this should be done, and then maybe form a domain overarching project to actually create this data elements repository. So now you know all our exciting projects, and you see we have a lot on our plate, so we can certainly use help. So if you want to help and contribute, you can apply for an IHE International Organizational Membership if you're not already a member. I have a link right here to it, and if you do become a member, you can check out if the other members. You'd be in good company. You can subscribe to our mailing list and keep informed of what we're doing. And I do need to point out that non-members, so even if you don't want to become a member of IHE, there's still ways for you to participate. One would be you could implement one of the IHE profiles and test them at a connectathon and send us feedback on what you find. You can also review and comment on supplements that are being published for public comment. And if you have a specific knowledge of something that we might need, we could also reach out to you specifically and ask if you want to help with that particular specific element. So with that, I leave you with a couple of links to other interesting places to check out. IHE International or Europe and North America all have their own web pages. I have a link to the complete program of educational webinars here, and if you want to check out other domains, IHE Integration Profiles, this is the main link. And with that, I'll open it up for questions.
Thank you very much, Riki. That was a wonderful presentation. I know that Nicole was going to let people know where this recording can be found.
Yes, thank you. On behalf of IHE International, we appreciate Riki and Mary's presentation. The presentation will be uploaded to IHE.net and also the IHE International YouTube channel. And I have posted those links in the chat window.
And Riki, we do have a question. The question from Andrea is, with some testing commonly performed in either AP or CP and or outside of the U.S. laboratory, testing may be performed in areas different than in the U.S. Are all the profiles able to be implemented in either AP or CP now, or are there limitations?
The IHE profiles are not specific. I mean, one of the reasons why we were doing the harmonization proposal or that harmonization project is to see if the very specific U.S. requirements can still match up with the international requirements. So the IHE laboratory profiles are certainly usable internationally.
Thank you. If anybody else has questions, please feel free to type them in the question and answer box. Okay, Riki, Andrea also wants to know, are they also usable in both AP and CP, or limited to one or the other? And she also says, great overview, thank you.
Well, thanks, Andrea. So the laboratory testing workflow is geared towards more of the clinical laboratory. And then the AP workflow is geared towards the anatomic pathology workflow. And as I was pointing out in this slide here, you know, we're really looking at the order the order and result reporting piece of it being pretty much similar across AP and CP, but for anatomic pathology specifically dealing with the image part of things. And there are more and more, I mean, one of the reasons why anatomic pathology and laboratory domain merged is because more and more other non-AP specific testing also is using images. And so there's more and more overlap in terms of having to deal with images in results. And so creating this new integrated laboratory profile that basically says, well, we don't really care if it's anatomic pathology or clinical pathology, but when you have an image, this is how you do it, is why we're working on that as one of the next projects. Did that answer the question?
I think so, yes. Thank you.
Okay.
Yes, Andrea. Andrea says
okay,
yes.
Good. Excellent.
I think I don't have any more questions that have come in. So I did want to ask Nicole one question. Where did you say the link for this recording is?
It will be on the IHE.net/webinars.
Okay.
And we also have an IHE International YouTube channel, and so it will also be posted there.
So is it here?
No, it's in the chat window.
Okay. All right.
Yeah, I don't see it in the chat window. That's why I was asking. No.
Okay, let me.
Yeah, I don't see it either.
Okay, let me see if I can put it in the Q&A and see if everyone can see it there.
Okay.
Oh, for some reason my Q&A is not working, so I'm sorry for that.
Well, you could, if you email it to me, I can stick it in the slide.
Okay, I will definitely do that.
Okay, I'm going to quit sharing so you guys don't have to deal with seeing my email.
Well, thank you again. We really appreciate you, Riki, and Mary taking the time to present, and we also appreciate the time that the attendees have spent participating. So thank you again, and we will get these posted, and look forward to the next time we all get together, okay?
Yes, thank you, Nicole, and thank you, Riki. Thank you, everybody, for attending.